Swayam Prabha. Digital India. Educated India.
Welcome to the Gyan course. The title is Systems Thinking Based Integrated Risk Management of Mega Projects. We're looking at a case study of high-speed railways in India. So my name is Maimura. I'm from the University of Tokyo, and I'm very excited, very honored to be here to offer this course together with my close research collaborator, Dr. Bugalia from IIT Madras. So I'm an assistant professor, faculty member at the University of Tokyo's Department of International Studies. We're part of the Graduate School of Frontier Sciences, which is an interdisciplinary program at the University of Tokyo. So there's various graduate schools, and the Graduate School of Frontier Sciences is one of the newer programs, graduate schools at the University of Tokyo. So there's physicists and economists and agricultural economists and engineers. They all work together on specific problems. That's what we mean by interdisciplinary or transdisciplinary, going beyond disciplines. So the problems I'm interested in at the Department of International Studies, we look at international development aid. So it's also known as foreign aid in some places, or foreign policy. So governments will cooperate and collaborate with other governments diplomatically to develop their economies or their industries. Like infrastructure is the biggest example. So the Japanese government and the Indian government have lots of ongoing projects on co-developing infrastructure projects, and that's where a lot of our past relationships, me and Nikhil, go back. I just joined the Department of International Studies recently. I used to study here, but before the Frontier Sciences, I was a junior faculty assistant professor at the Department of Civil Engineering. So that's where I started doing research on civil engineering and infrastructure management problems. But I did my PhD on international studies, so the development aid projects that I was talking about. Except for Japan, a lot of the development aid is infrastructure and civil engineering projects, so that's why we do lots of research together. Master's also in Japan, and maybe you can hear my English. I'm not Japanese. I work in Japan, but I'm actually from Canada. Born and raised in Toronto, Canada, and I went to my undergraduate studies were in Hamilton, maybe like 1 hour away from Toronto. That's where I studied linguistics and communication studies. So I'm very soft, humanities-based academic career, but I work with engineers and management people in the construction industry, and that's where I met Nikhil when he came as a PhD student to the University of Tokyo. Okay. Please interrupt me if you don't. I know I talk too fast sometimes, and maybe my accent is not too familiar for you, but if you need me to repeat things or tell me to slow down, just look at me and tell me to slow down. So I'll try to speak more clearly. Okay, and I would also like to welcome Nikhil to introduce himself, perhaps.
Thank you so much, everyone, for coming all the way. I know it is a busy week in IIT Madras academically, and some of those who could come from outside. Really appreciate it. And it is my pleasure to have you, Professor Yu Maimura, here. He is my co-supervisor in the PhD, and it really feels very pleasure moment for me to share and develop these slides together. We are very excited about this course. A little bit about me. Like he was telling, I'm a core civil engineer that way. I do not come from linguist background or interdisciplinary background, but my research outlook over the years has been a little bit more interdisciplinary. I did my bachelor's from another IIT Kanpur in 2013. Again, core structural civil engineering related topics. Then, like most of the IIT students, I actually did a job in data science for one and a half years. Then realized that, okay, no, civil engineering is still very exciting, and that's where I decided to go for my master's. And my master's, I was working a lot more on concrete materials related research. Again, did at University of Tokyo. And then this is where I got introduced to a lot of these concepts of international projects, infrastructure projects, while I was taking courses at University of Tokyo. In fact, Professor Maimura was also teaching one of those courses, and that exposed me to this huge new area of what engineers are actually required to do on the field and how complicated it is. It's a wonderful technological solution, but it doesn't work in the field, and that kind of excited me. The management aspect of it kind of excited me, and that's where I switched to the construction management research and infrastructure systems research group, where Professor Yu was there and working closely with Professor Ozawa, who was my PhD supervisor. When I was doing PhD, this India-Japan relationship was growing faster and faster, and one of the projects was this Mumbai-Ahmedabad high-speed railway project, which was the MOUs for that were getting signed, and a lot of interesting discussions were happening on the time. So that's where I thought, okay, this sounds interesting. I can contribute to India and Japan both. I'm in Japan at that time naturally, and it's a very fantastic opportunity for me to learn because there's a lot of push from Japan's side to make the technology export. So that's where we started exploring. And of course, it's a technological system very well established in Japan. So there was nothing that I could do as an engineer, but we got interested in, okay, how do you efficiently manage such a system, and will India be able to replicate such a system once the comes in India, right? So human resources are different, rules and laws and regulations and policies of a country are different. We cannot adopt the same Japanese copy paste. That's where these kind of discussions became interesting, and then we ended up choosing a topic called safety, which is like one of the most aspirational point about the Japanese high-speed railway. Everyone in the world knows them for the safety. And that's where Professor Maimura helped me a lot, shaping my arguments. We worked closely together, and a lot of interesting outcome that came out of that. We will force you to study some of that outcome as part of this study. But I just wanted to emphasize, bring your engineering hat out of like a little bit, try to understand the interdisciplinary part. This is not going to be a core technical course for the next couple of days. But it's really about thinking broader, thinking more interdisciplinary, and be contributive. Like it's an opportunity for us to also learn from what are your ideas, as well as for you to also benefit from the perspective that Professor Maimura will bring it. Of course, I'm here, and post the course also, I will be happy to assist you in whatever material and all more studies that you require, but make best use of this opportunity and make the class very interactive. And this course has been designed like that. We will force you to be in a situation where you will be required to collaborate, talk to each other, come up with some group discussions and participate, right? So yeah, with that, I will bring it back to Professor Maimura. Over to you.
And so the papers and the output he was just talking about, these are the main papers that a lot of the content of this week's lecture are based on. Some of the theoretical and also case studies come from these three papers mostly. One of them is called The Organizational and Institutional Factors Affecting High-Speed Rail Safety in Japan. A lot of key messages here, but our boss, his supervisor, it's the background of this paper is mostly, it's technology will only take you so far. Once you get into mega projects, once you get into government projects, once you get into international projects, we are also very likely to face risks that we don't understand from a technological perspective, because so many people are involved. That's also a safety risk. So the organizations and the institutions involved can also have a very, very tangible impact on performance of infrastructure services. The second one, this paper actually, I think we did first, but this one was more about policy. India is developing its high-speed railway technology right now, very fast and soon to be a leader, I think, globally. Taiwan was going through the same experience maybe a couple decades ago. They also borrowed Japanese technology, but developed a lot of local capacity as well. These kind of stories is we talked about in the second paper here. And then it's not just very high-level organizations that we're looking at. sometimes we zoomed in a little bit on teams and the people working the actual projects, and we also looked at how safety was being managed and maintained on site. So this is a system dynamics model for near miss reporting in complex systems. Okay. I suggest you read the papers. We don't want you to memorize and understand all these papers perfectly. This is just research. These are types of papers you can do on this topic. But hopefully over the next week, we want to also tell the story about how we came across these topics, or how you have to collaborate with the industry to find problems that matter, and finding the arguments within the research is also part of what we hope to share with you this week. Okay. These are the objectives of the course, the stated objectives of this course. I think before you signed up for it, these are what we hope you will leave this lecture with. So the first objective is to introduce the concept of integrated risk management of complex infrastructure projects with ongoing high-speed rail projects as an example. So integrated risk management is a concept that we think is important. It is quite specific in the literature compared to other risk management approaches, but we want to explain this concept to you, which is theoretical, but theory is only abstract sometimes. So understanding theory always helps if you have case studies. So that's why we're using high-speed rail projects as an example to help you understand the theories and frameworks associated with integrated risk management. The second objective is to provide you with an appreciation for the complex and dynamic risks associated with HSR projects. So these are bold for a reason. Complexity is a key word that's very important for our class. There are different types of complexity, and we will try to help you have a better definition of what it means when people say this is a very complicated project. We want you to have a better understanding of what you mean by complexity. And then dynamic is also semi-related to complexity, but it's not just how complicated the contents are, but how interconnected everything is. That's also a definition of complexity. And interconnection is a definition of dynamics. And so we'll be introducing that concept as well in the lecture, especially in day 3. The third objective is to equip you with the frameworks and tools necessary to understand the complexities that I'm talking about and the impact that they might have on the projects. So the first 2 days, I give you lots of information about HSR, what's actually happening, these kinds of technologies. And then day 3, we try to give you a specific tool that might help you understand how we can try and measure or observe or simulate or even just play with and understand how complicated things are. And that will be the system dynamics, which I've mentioned a couple times. Okay. Finally, we want to enable you to identify evidence-based suitable management and policy interventions for the successful management of infrastructure projects. So the tools help you see things, they help you measure things, but tools in themselves are not inherently valuable. It's how you use them, or who you can convince with them, right? So Nikhil's team is trying to develop tools that will help us evaluate or simulate or argue for specific policy interventions or management implications. So the goal is not to simulate things well. The goal is to convince people that this is better or safer or cheaper or faster, right? These are the things that the management people have to decide and that we have to try and implement when you're younger. In 10 or 20 years, you will be making the management decisions and telling people what to simulate and what to manage, right? Okay, so those are the 4 high-level objectives we hope you will come out with through this lecture. Okay. So today is some background on what I mean by these infrastructure systems, the complexity that I'm talking about. I'll give you some more definitions to help you have a better understanding of how to define complexity by talking about infrastructure systems. And what's good about being specific about infrastructure systems is then it helps you be specific about risk, because everybody, I think, has a different definition of risk within that system. And so that's what I mean by infrastructure risk management here. Tomorrow, I'm talking mostly about Japan today. So tomorrow, we take a step back and also think about some other countries and different experiences they've had for HSR development, such as Europe and China and Taiwan. And of course, what we want you to do, or what we need to do here, is think about the implications for India. So these are the lessons that are happening. These are the lessons that have already occurred. What does this mean for us, right? What does this mean for your future? Because it's happening right now. Day 3, we introduce the tools, some systems thinking, as well as more specific modeling definitions. And we will show you the models in the papers I just showed you and try to explain them and then help you tweak them a little bit to see how they behave when you start changing parts of the model. Day 4, we continue, get more deeper dive into the models and thinking about how they should change or what they should change. And then the final day I always save for looking back and remembering the contents. So we will reflect and review. And also we've invited Professor Ashwin Mahalingam from the IIT Building Technology and Construction Management course, professor who also has tons of experience implementing policy implementation for trying to get people to use systems thinking at a higher level. And we wanted to ask him to share some of his experiences as well. Okay. Once again, feel free to interrupt me if you want more information. This is what everybody is probably most interested in. So this is how you will be evaluated. 40% for just showing up and raising your hand or talking to your classmates. I have a lot of discussion exercises to try and, before I define things for you, I ask you to try to define them first, and then we have a discussion. That's my normal way of class discussions. So just talk to your neighbors and then share your ideas so we can move together. That's part of the 40%. And 60% we will give on a report, an assignment. It will have 2 parts, 2 big questions, so 30%, 30%. We will give you the details about this on day 3. And it will be due a couple of weeks after Friday. So not immediately. We give you some time to maybe prepare the final assignment. We'll give you a certificate of completion or certificate if you get 70%. So yeah, you need at least, if you get full marks, if you show up every day, you still need 30% on the assignment. And if you don't show up, you have to show up at least, I don't know, twice or something. If you get 100% on the assignment, which is impossible, because you have to show up to get marks on the assignment. But again, I think our contents, there's no textbook for this yet. So there's no correct answer. There's no marking guide. ChatGPT will not give you the answer yet because none of them exist. So, it's hard to get 100%, and it's hard for us to also give you 0%. It's because the point is we need you to engage with the ideas and try to put it together. So the assignment, I think, is relatively reasonable. You won't be getting a very low mark if you just pay attention and try to put the ideas together. Okay, so today there's 5 days, and I'm taking most of the first 2 days and then the end. So today I've tried to separate the contents into 2 parts. So the subtitle of the first part is developing and managing good infrastructure systems. So I put good in quotations because that's the kind of discussion I like having. What do we mean by good? You know, what's the definition of good? It's a very difficult question actually to ask. So the background is, and so the subtitle is developing and managing good infrastructure systems. So I like to break down the title into key concepts. So first I describe infrastructure systems. I want to define this term for you, this concept. And then also I will give you some history about developing and managing infrastructure systems. So I'll give you examples from Japan. And then how difficult it is to be good, or what define good. Those are the purpose of the first half. Okay. And then the second half, I'll introduce risk management specific to infrastructure. So what kind of risks are there, or what can we do about risks, and give you some examples. Okay, developing and managing good infrastructure systems. Infrastructure systems is a key concept for me and my group, and as well as for Nico Sensei as well. Are you all civil engineering here? Is anybody not civil engineering? I don't want to point you up. I'm also not civil engineering, so okay, yes. So we are all not civil engineering, so you should feel comfortable here. But this is from I remember I was a linguist, and I also do language studies now, actually. So I'm very interested in the words and etymology of concepts. So infrastructure is actually, it comes from Latin, went through French, and now we use it in English as well. Infra is the Latin word for below. It means below. So infrastructure is below structures, right? The foundation, basically. That's what the word infrastructure means. What is the thing that supports structures is infrastructure, right? Supporting elements, structure under structure. It's a meta concept. So what the big concept of infrastructure means is, how do we support things, anything, your life, the structure, this chair, my weight. That's what we mean by infrastructure from an etymological perspective, just the definition of the word. So as a civil engineer, you're thinking, how do I support civilian life? That's your vision. That's your mandate, or that's your goal as a civil engineer. Okay? Supporting society and human activities. So an infrastructure system then is about a system that creates those supporting services or support mechanisms. This is a big framework that my supervisor is Professor Horita, and Nikhil Sensei's professor is Professor Ozawa, and they work together on a textbook in Japan that's quite influential for conceptualizing infrastructure services, and this is their framework for infrastructure systems management. Okay, this is what we mean. Basically, the people in our research group back at the University of Tokyo, our research can sort of be divided into one of these concepts. There's many things that we talk about in infrastructure management research. But in general, the industry is sort of structured like this. You do some surveying, and then you do some design, and then you construct, right? And you just keep doing that over and over again. Once the service is completed, you either give the service to the owner, or you start operating and maintaining the facility. If you are government, or if you're a large organization, then of course you want to evaluate the quality of your service, or evaluate the efficiency of your management decisions, or whatever it was. You want to learn something from your experience by evaluating and monitoring the progress, and then you take those lessons to conceptualize what you must do in the next planning phase, right? You don't want to just do the same thing over and over again. You want to constantly improve the cycle. So the planning or the surveying of your next project should be informed by the evaluations and the lessons you learned from previous projects. So this cycle is important for not getting stuck and losing to your competitors over the long term. This kind of mentality is what we mean by this cycle in the middle here for infrastructure facilities cycle. But depending on the type of infrastructure, depending on the type of company, even depending on the country, there are different ways of contributing to this infrastructure system. IT, there's a lot of technology you have to develop. There's a lot of information you have to manage. That is also a topic. If it's a big organization, a small organization, a traditional industry, a very new industry, there are practices and conventions that you might have to overcome. Depending on the organization or institutional structure, again, there's certain things you can do and certain things you can't do. And of course, do you have the people? Do you have the money? Do you have the time? These are also important topics. So all of these do have to come together for you to help manage and maintain a very productive infrastructure system. Ultimately, which is the whole point, is you just want to support the livelihoods of people. You want to improve people's quality of life, or you want to support industrial activities. So Nikhil sort of alluded to this about how our lab in Japan was very open to this, what some would say is not traditional civil engineering mindset. But our boss, Ozawa Sensei, is a concrete engineer. He's a very famous concrete engineer. And he always talks about how and why he created the management research group in Japan. And so his early research was on concrete technology. That was his PhD. He had to create self-compacting technology, or self-compacting concrete, high-performance concrete in the 80s and 90s. And he developed it. He didn't patent it. He kept it open because he wanted the industry to start using it. He went to the ministry for a couple of years to work as a bureaucrat as well, to get the public procurement people to start using this new technology. And he found that it was impossible. You have a new technology, but the public procurement rules and the laws don't allow you to use untested technology, right? So that's when he realized, I created a very good technology, but the market, the organization, the management is not ready to use it. So who's doing research on the management? Why can't we, what should we do? And that was the original origin story of the management group at the University of Tokyo. So yes, it doesn't matter if you have the perfect technology unless the organization, the management is ready to help you exploit it, right? So they go hand in hand. And this is why it's important to also consider the management implications. Okay. So when I look at this, I think I like to look at this framework and try and break down my research topics sometimes. So safety management would be, there's lots of hard technology talking about safety, right? You can have sensors and braking systems and things like that. But they will cost money. How much of your budget do you want to spend on safety as opposed to advertising, as opposed to, lobbying? Do you set up a whole safety bureau, or do you outsource it? Or as a government, how do you enforce safety? Or how do you create new laws about safety? How do you convince people that have never worn a helmet in their whole life, that's their convention, that they should start wearing helmets, right? These are all different ways of thinking about safety research, for example. And I look at more policy and international development aid, but also think a little bit more about resources and finances and the organizational, institutional structures for supporting infrastructure. So the people, this is, sorry, not a very poor quality metaphor of livelihood. I just put some people up here. This is people happy. That's what I'm trying to convey here, people being happy. So infrastructure has to make people happy, has to improve their quality of life, or it's not, I don't think it's meaningful. So, but there's many ways to do that, right? So there's many types of infrastructure is what I'm trying to say. This is where things get very complicated, not in a good way, but also quite literally. These are the bureaus of the Ministry of Land, Infrastructure, Transport, and Tourism in Japan. Okay? The Japanese government, massive organization, hundreds? Probably more. I mean, yeah, hundreds of billions of US dollars of budget every year for procuring and also maintaining and creating new infrastructure services. High-speed railways, we're talking about the Railway Bureau in, I guess, in general. But it's not just them, because they have to figure out how to get the land permits, or maybe they have to buy the land. So spatial planning, they have to work closely with them. Also sometimes the Housing Bureau, because people might live there already, or water as well. Lots of natural habitats and ecosystems you have to consider when you're building kilometers and kilometers of railways. And it's big business, obviously. It's a huge industry. So you have companies that want they want to be involved in the process when you're thinking about how to pay for these things, or how much they should cost, and all of these issues. But yeah, as an academic, these bureaus are very frustrating. I don't know. They're not very logically. They're not. It's such a messy categorization for academics, I think. So I always feel uncomfortable looking at how these bureaus are organized. But I think governments everywhere are like that. It's probably not just Japan. But so I wanted to ask, when you think about infrastructure, who are the main government offices or ministries that you think about? That's just a question. I need you to give me an idea of the situation in India. Does anybody you can just shout out some offices or ministries, or I don't know what else. What are they? You have ministries in India, right? It's parliament. Ministry of Road? Ministry of Road. Road, housing. So, okay, road is the same. Housing, urban planning? Urban development? Civil aviation as well. And it's separate from the military aviation, I guess? Yeah. Okay. Oh, yeah, that's true. Japan will also have a self-defense bureau, I guess, that also does the self-defense aviation, I think. Maritime. Yeah, Japan's similar. They have hundreds of, what are they called? Independent administrative agencies. So they work for the government, but they don't have to report to Parliament anymore because they're independent. And they have to answer to the minister, but they get to operate independently. Those are the agencies. But I'm not sure about water in Japan. I think it's sort of, they're trying to privatize, but it's mostly just it used to be a public office that now, same people, but they're just called private now. So it's quite strange, I think. All right. Yes. So every country, lots of types of infrastructure. Every country will try and define it differently, I think. But there's also the political history, I think, behind why these bureaus are structured like this, right? So that's something that I need you to educate me on in terms of the Indian context. All right. Yes. So high-speed rail, again, we'll probably focus on railways, but again, just for that, you have to buy land, you have to set the standard, you have to get the energy ready, you have to lease agreements with people that want to use your service. All these other people will get involved, not just the Railway Bureau. Okay, that's something that I would like you to consider. Okay. Back to this framework that I'm trying to introduce to you. So it's very complicated, infrastructure systems. Another way to think about it is that high-speed rail is a type of infrastructure service that we're giving within this very complicated system. This figure from our professor's textbook is a little bit more general, so it considers all of the other high-speed rail, other than high-speed rail. So this is what Nikhil Sensei created, developed as part of the literature review during his PhD, I would say. I think if my understanding is correct. This is what it would look like, I think, more specific to high-speed rail. So I'll be using this a lot when I'm giving examples or talking about stories about how complicated the HSR system is. Okay? So in the middle, we'll have more the facility. This is in the Japanese case, this is the Japan Rail. This is India Rail. This is what they have to do in the middle. This is the hard technology or the actual operations that they have to do. But the things that impact it are the operations management. You have to maintain your facilities as well. You have to develop the technology and the system to do those things, and it also evolves, and you have to think about the future. All of this, you have to pay your people, and you have to borrow money to do this. But those are the things under their control. You can only, as a company or as an organization, you can control these things, but you will be impacted by higher level policy, national laws, regulations, social movements, social differences, and just general market conditions as well. And this is also another dimension of complexity impacting your system. Any questions about the infrastructure systems framework that I'm trying? It's a very high level framework I'm trying to introduce to you to help you organize a lot of the complexity that I want to bombard you with over the next day or two. Okay. So if you don't feel uncomfortable still, I think it's okay. I'll try to give you examples. This is operations management. This is what I mean by development, not evolution. I think that will become clearer to you as we share more examples. But yes, please. I also encourage you to criticize this framework because we need to improve it as well, right? We want to figure it out.
Policy, I think in that sense is a bigger word because of course whatever macroeconomic policy will change the outlook of the market condition. But here we are looking at policy specific to high-speed railway system or a railway system. For example, Ministry of Railway comes up with certain ideas that this is how you should operate trains. Or for example, right now in our country, Mahakumbh special should run. So that's a policy directive given directly by the Ministry of Railway Policy. So those is a directive, but of course the overall macroeconomic condition will be captured, and therefore there's also a double arrow. So whatever you do affects it, and then this also affects that. So yeah, it's an of course simplistic diagram, and any systems thinking is actually making simplified of this large, big, complex reality. But you are absolutely right otherwise. Yeah.
Mm-hmm. Yeah. Well, I'll probably repeat this many times, but yeah. So what's very interesting for us in Japan is. Yeah, it's the context is completely different. I mean, Japan wants you to use Japanese technology, but to be honest, I think nobody knows, right? It's whether it works or not will depend on the market society conditions, and it's too different for us to know. It's in the end, it's always a local solution, right? That is sustainable. What we will talk about immediately after this about demand risk. So this is exactly demand forecasting. Is not as sophisticated as you would hope in Japan either, I guess is my answer. And I think I'll describe this here, but yeah, because a lot of it is for justifying financial goals sometimes rather than the market goals. But every country struggles with demand risks and reaching ridership, projected ridership goals. So thank you for the excellent introduction into the next topic, actually. Okay. Not plan. Yes, he doesn't work for us. I just met him, so it's okay. Okay, but sorry, I forgot. There's another story in between. So please, if I don't answer your question, remind me, and we go back to that topic at the end of the lecture. Sorry, any other questions about the framework? I think a key concept would be redundancy, and again, it depends on the problem you're thinking about. So for safety, redundancy is good. You want more people looking at it, but for management or efficiency, redundancy is bad. We already have 2 people doing this. Why are we paying you to do the same thing? You want to get rid of redundancy. So that's for some systems engineers. They're trying to identify the clash so they can get rid of it. Or for some systems engineers, you're looking for something that you want to protect with several layers of redundancy. Those would be two ideas that come to my mind in terms of.
Part of it is also to make people first realize that what they are doing is actually creating conflict for somebody else. This is one of the biggest problems because a lot of time the true impact of our work does not reaches back to us immediately, right? For example, if I'm doing something bad in a company sitting in a corner, and if it is creating problem for your co-worker, that co-worker also has no idea why his or her life is getting miserable today, because they don't see the connections, right? Maybe they'll complain to their boss 2-3 months, they will do some root cause analysis and they'll figure out, this was triggered because of this, right? So part of the systems thinking is to actually map the system in such a manner so that you realize that whatever actions that you are taking, of course you are getting impacted maybe, but a lot of time impact goes to the different organizational boundary, although you are still part of the bigger system. So visualization of that actually makes it immediately impactful and you start thinking about it, right? So that's one thing. But again, system dynamics will not tell you, it will just tell you optimal answers. It is not a tool to tell you how to achieve the optimal answers, right? That is, again, nobody can simulate. How will you react to this equation? Nobody can simulate that. But it's just to make you realize all these things. Yeah. Oh.
So we'll take a little, changing the topic a little bit to give you some more information about Japan. So the subtopic is developing and managing good infrastructure systems. So I'll give you an example of how Japan has developed and managed their Shinkansen high-speed railway line. Most of this material actually comes from Japan Rails themselves. Has anyone ever ridden, taken a ride in a high-speed train somewhere in Europe or Japan? No? Okay. When is the one in India supposed to? I shouldn't talk about that? Okay. Yeah.
I think the estimated is 2029.
29? Okay.
Yeah.
So probably like 2039 or 2040. I'm just joking, but yeah, Japanese Shinkansen lines were also delayed quite a bit. It's a common story, I think, globally. This is a map of Japan you'll see here. Northeast, southwest side, various big cities in between, and then Tokyo is in the center here. Tokyo Disneyland, stuff like that. Osaka is another big city on the west side. Toyota headquarters is closer to Osaka, but it's on the west side actually. And then all the big finance banks and stuff are in Tokyo. And those are some markets that you have to connect, for example, with this. But I'll show you some history from Japan Rail's story about how their Shinkansen, their high-speed railway line, was developed, historically speaking. So they divided it up into 3 phases: early development, rapid expansion, and modern 21st century development. So it's very old. 1872 is where they would talk about the development of their first railway lines. It was a national, it's government-owned, national projects. This is where they start introducing, nationalize the company, try and develop technology, railway technologies, very early days. And it was also a part of the post-war reconstruction of these areas. There's lots of wars going on, even before World War I and World War II in Japan. So even before World War II, they were developing this technology. And then actually after the war, they had to negotiate with the American government, and actually, so the World Bank actually helped fund the construction of the first high-speed railway line. And then once that succeeded and started actually providing very high-quality services to the people, government said, okay, this is an amazing idea. We need to do this everywhere, and they started expanding very quickly. So that's 1965 up until the 21st century. You'll see that after official commencement of operations, they will start rapidly expanding the network, and at the same time developing technologies that for problems that they identify in other areas. And now we're seeing it's a very mature and developed system. Population in Japan is not growing, it's declining, so domestic market is completely saturated, so there's no need to expand for domestic people. If anything, we want to figure out for international tourists how to improve services. These are a different kind of technology development and service development that's happening right now. Okay, I'll give you some examples of very specific challenges they faced during each phase. Okay, the early development phase, so this is 1800s, 1900s. Initially, they chose the narrow gauge for their railway lines very early on because it wasn't high-speed rail, and they found, I guess, what eventually that makes them realize that it wasn't going to help them expand. It was the limiting factor constraining their expansion plans because of this gauge. So they decide very early that they have to switch to the standard gauge to support the higher speeds and greater transport capacity. What they also teach in Japan is that East Japan and West Japan actually use different gauges for a while, and then once they, at some point they have to connect to each other, right? And that was also a very difficult problem for them to solve with regional competition happening, which I think is probably relevant to India because you're such a huge, diverse country. Who wins the standards war in your market is going to be a very interesting story, looking back on it historically. Challenge number 2 was money, funding shortages and pressure from the government finances, and the public were getting upset because it looked like a waste of public money. And they were very, very constrained. And then wars started happening and they were getting even more constrained. So one of the solutions that occurred at this time was the national government had to borrow money from local governments to help finance these projects, as well as reaching out to the Americans, World Bank. And I won't say luckily, but at the end, the Osaka-Tokyo connection did run relatively successfully, and the demand projections would justify the investment. They were able to find this, and so the project was approved and went forward despite a lot of public upset people. World War II happened. And I don't know if you've seen firebombed pictures of Tokyo, but yeah, the whole country was basically leveled, especially some of the big cities. And you built up a lot of your infrastructure for decades and decades, and then you go to war, and then everything is destroyed. It's starting over, but that includes not just the construction, but they decided to reevaluate some of the plans. And this is where the Tokaido Shinkansen concept was born, I guess. Tokaido connects Tokyo and Osaka as well. So sorry, some of these, even I'm not very good with these. Sorry, that's these Japanese words. So Tokyo and Osaka are cities, and I guess the pipe that connects them, they would refer to as the Tokaido, which in characters would be the S, or the Eastern Sea corridor, I guess, that's what it sort of means in Japanese. Okay. Major technological challenges at this time were just power, not enough energy. It requires massive energy to run these high-speed trains. Aerodynamics, nobody had gone this fast before, so they had to figure out the very iconic, pointy nose. Well, if you look at the first one, it doesn't look pointy at all. It's kind of like a cone. And now it's just getting longer and pointier. So it's very interesting to think about. Technological development from a historical perspective is that as well. Wheel-to-track adhesion, braking systems, you're going so fast, how do you stop? And then structural strength and vibration reduction. These were the technological tasks that JNR was giving their engineers very early on.
JNR stands for the Japan
Oh,
National
Japan National Railways. JNR, and then it became JR, no longer national. Right? It became a private company. Although it's not, it's also owned a lot by the government, but anyways. Okay, so once you kind of establish the technology and some people start using it, trust builds up, and you have sufficient users and satisfaction, some money coming in. Okay, let's expand the service. It's working in Tokyo and Osaka. Let's get this to work in other regions. Expansion will come with its other challenges, right? From a regional sort of I want to say not political, but you'll have other big cities in other parts of Japan complaining, like, why don't we have a high-speed rail link? Right? Why is it just Osaka and Tokyo? That's not fair. That's probably also going to happen in India, I think. Once people start enjoying a service, other regions will demand that they also get that service, right? Especially if it's publicly funded or if it's an investment by the government. These kinds of voices were very prominent in Japan as well. So the Shinkansen network is expanded. These were also feasibility studies were done to figure out in which order you want to expand, but you start with the high demand routes and you get Sanyo and Tohoku and Joetsu lines. Again, these are not cities, but these are words that talk about the connection. So west, northeast, and Joetsu is southern Japan? I can't, sorry. Yeah. So everybody wants the lines, but nobody wants to pay for them. So funding issues obviously come up. So this is where the Japanese government actually set up a shared funding model between the central and local government. So I guess the early ones were very much covered by the central government, but they don't want to bear the whole cost of all this expansion. They'll ask, if you want a line so badly, you have to help cover the cost. So it's a shared funding model. And they also combine it with the leasing mechanism. It's called jogebun. They separate the top and the bottom, they call it in Japanese. But so you separate infrastructure and operations. So we'll still own the infrastructure, and you can lease the right to operate the high-speed rail lane on it for 10, 20, 30 years. That kind of that was the mechanism. So it's similar to what you'll see in Europe right now. We'll talk about this tomorrow, but and then it actually changed again in Japan after it was integrated. But we'll talk about this as well. Governments have different decisions on how to structure the business. Okay, we keep ownership and you just get to use it, or that's the leasing maybe, or we won't technically own it, but we'll just give you all the rights to maintain it, and you just have to provide the service at this level, or else we don't pay you. These kinds of, there are very different ways that you can negotiate the rights to transportation line. 90s Japan, late 80s, late 80s, 90s Japan, extremely rapid economic growth, coupled with extremely disastrous environmental protections and a lot of social unrest as well, and health scares and things like that. So the public got very sensitive to environmental issues as well, and just huge infrastructure projects and very fast trains going through people's neighborhoods. People were complaining about the sound, about the vibrations, about the damage. So the HSR companies had to also invest in these technologies that don't impact the people as much or don't impact the environment as much. So social environmental considerations became a key component of the organizational structure in the 80s and 90s as well. So I don't know if you'll see, it's very interesting to see in Japan from far away. You'll see, it looks like a tunnel, but it's elevated, and and you can't tell. Sometimes it's a highway because the surrounding neighborhood complaining about the trucks. So they designed these soundproof acoustic shaped tunnels to cover the highway, and they have the same thing for the high-speed Shinkansen rail lines to block the noise from disturbing the neighborhoods. And then you also have regional challenges like snow and heat. So this also happens a lot. You have regional technology, what are they called? Research departments. So northern research departments specific to like snow resistant or cold resistant technologies. And then you have the coastal focusing on the salination and salt. You get local technology development also happening here. Yeah, that's part of geological and engineering challenges. Okay. Today, so we still see a lot of environmental and operational risks happening. It's a very advanced technology, thousands of people using it every day. So you don't want to wait for an accident to happen, right? You kind of want to prevent them from happening. But one of the big, obviously, context-specific problems for Japan is earthquakes. What happens if an earthquake happens and we're going 200 kilometers an hour? It's very scary to think about. There's lots of technology for early response and automatic braking systems that we also talk about tomorrow. You want to keep improving safety, but you need to stay operationally efficient. You can't lose money, but you can't lose lives either. So that balance is constantly challenging the operations companies. So lots of inspections, lots of crack detection vehicles. They have trains that you put on the track that will go and actually monitor the train for you and identify things that you have to fix and maintain. And maintenance plans and schedules as well. Okay. I think something that's interesting about the Japanese management approach as well, for a management culture perspective, is a lot of our colleagues at the University of Tokyo will get hired to work for JR, Japan Railways. And you would think they're quite elite universities, so they go straight to management kind of a post. That's not true. They usually, for the first year or two, have to do train signal operations. They'll be waving the flag, liaising with the users, and also they have to wake up all night and they have to monitor the tracks and also accompany the maintenance team to look for cracks. They want to garner a sense of ownership and responsibility for the actual infrastructure maintenance crew as well. Yeah, and so the earliest lines are already 80 or 70, 80 years old or something.
60 plus.
Yeah. So the life cycle at the time was probably 30 to 50 years design specs. So some of these have to be completely overhauled. Some of them are being maintained and reevaluated for how long they will live. But Japan is also going through a complete overhaul of their existing infrastructure system that they built during the 80s and 90s. Operation and maintenance is a huge topic for research in Japan because the demand is massive. Yeah, and as I said, they're a private company, so they do have to make profits and provide services and win their customers. So the government is not going to protect them in all circumstances. They probably will protect them a little bit, but not if they're being irresponsible. One of the main priorities they have to make as a private company to win customers is that you have to be more convenient than other modes. Don't take the train, or don't drive, take the train. Don't take the plane, take the train, right? They have to win in terms of either cost or quality or safety or whatever it is against other transportation modes. How do you get the traveler to use our services and not the other transportation modes? So as a private sort of market-based system, that's how they want the system set up, is they want the competition to help improve their services as well against other transportation modes. All right. Okay. So those are the three. It's again very simplified story about dividing it into the first phase and then expansion, and now things are changing. I was thinking about how this might relate to India. I guess simply, if we want to simplify, India's probably in its development phase, early development phase. These early choices that the industry makes may have an impact later. So Japan didn't think about how the narrow gauge would impact its expansion plans decades later. So it's what kind of decisions are you having to make now, which could impact some other phase in the future, because we can't really predict technological advancement that much, right? But there is very much the potential for a decision now would constrain you in the far future, medium to far future. For technology, a lot of that, I guess that means whether you want to develop it or develop it yourself or import it. International standards or domestic standards are also something you always struggle with when you're making technological decisions about standards early on. I don't know enough about, I haven't read enough local news to know how angry the public is about expensive infrastructure projects, but I think this happens everywhere, but I don't know what it's like right now in India. What do you think? Yeah? How who thinks the public are generally happy that they're developing an HSR in Mumbai at the Barbad? No? Yeah. Who thinks in general people are pretty upset? It's probably a waste of tax money and yeah? Okay. And everyone else is neutral? Yeah, or probably leaning towards upset, like high government spending, kind of wasteful. Yeah, I think that's quite natural. Also, that's what I mean by political agendas here. This also happens in Japan. Politicians will use massive infrastructure projects to win votes, right? It's jobs, it's money, it's development, it's connecting their hometowns, stuff like that. It's real and it's just inevitable, I think. India will be using international financing, I believe, for some of it. So people are usually worried about being in debt to the international system or China or whatever it is. So that's usually controlled by how much you want to borrow from other countries and then how much debt that creates for your future generations and then the public acceptability. Okay. War interruptions happened in Japan in the 40s. Material shortages happened here. Russia, Ukraine, inflation, it's actually happening here now too. You think war is not relevant, but it's happening today, right? Geopolitical instability, inflation, global economic forces. This is massive instability right now in such a complicated global market. So I think the HSR projects in India also have to consider what happens if we can't buy Russian oil anymore, or what happens if concrete prices go up even more. They just keep going up, and labor. All of these questions add to the risk and instability of these projects. Technical hurdles. Again, probably similar to the first point, but there are decisions that India has to make right now about what technology or what level of technology they want to use for this project. I think somebody was telling me about if they should buy the carriages from Japan or Europe, or they want to create them themselves. There's domestic manufacturing capacity or buying expensive things, but you get to use them right away, or do you invest now and the project is delayed? This is a trade-off that is also being made right now, I think, in the Indian context. Does anybody else have what you think is a unique Indian challenge to what you think is going to be very difficult for developing HSR nationally? Okay, so the question was, the cost. How much should we, it is a high advanced service. The majority of the population probably cannot afford it yet, I guess. Well, it depends on what you've decided to charge them. But pricing, again, a very big concept that we will include in the models in the next coming days. Demand is also a function of pricing, which is a function of the supply. So how much can you charge? Is anyone going to use it if we charge this much? Or these issues are also unique to the Indian context, perhaps. But we have a slide later, actually. Interestingly, though, from an economic perspective, 1960s Japan and India, I guess whichever line they're making right now, from GDP per capita type statistics, it's actually it's more similar than you'd think. So, Japan was pretty poor in the 60s as well, but they were still able to get people to use the services. Okay. Yeah, excellent. Yes.
Yes, so overlap of different transport modes in India. India has adopted a lot of different avenues of transport, right from two-wheelers to autos to bus corridors to now metros, and then again if you move on to high-speed rails, the segment which you want to target on becomes a challenge. I mean, it's a part of demand forecasting challenge, but another challenge is idealness or less utilization of the services which we made before. So
okay, yes. So overlap of the services, but also not just in terms of congestion or usage, but if you're basically competing over the demand as well. So using something will impact the user's number of something else. What does that mean for the existing services? Yes, also an issue. It's a dedicated track is happening, right? Okay. So yeah, I think Japan has been trying to export Shinkansen technology for decades, not just in India, but obviously they do a lot of work in other countries as well. Yeah, dedicated track is a must for them, obviously, and a lot of developing countries do not want to pay for a dedicated track if they don't have to, right? So it's very difficult for the Shinkansen engineers sometimes to sell the idea of how important it is for the dedicated track, because also it has, I think, less impact on some of the other transport modes if you can use it as well. And it helps maintain the highest service quality in the Japanese perspective in the long term. Okay, interesting. So yeah, the disposable income, how much are people willing to pay? Lots of land ownership laws are very different in different countries. So I'm not sure how challenging that would be, but yes, it's always difficult in any country.
Skilled and team to operate and manage the high-speed railway.
Oh, yes. Okay. Excellent. So we were, up until now, we're thinking about, I guess, constructing and completing it, but yeah, who's going to drive the trains and who's going to operate it afterwards? The capacity building that's needed for the human resources, which is in the framework, to actually operate it. But I don't know. I thought there's so many young, talented people in India. I didn't think that was going to be a problem. I just figured you have till 2029, 2030.
You can ask how many of them want to work for India.
But I guess top engineering, yeah, sometimes you want to manage the teams. But actually, that's true. So, sorry. Sometimes it's not the higher education, but you have to have what's it called? Yeah, the skilled labor, or sorry, I'm drawing a blank on the type of system. The German education system is very famous for
Skill-based.
Yeah, the skill-based labor school. So you create basically another tier of education for skilled labor. Shorter, you don't have to do 4 years. Vocational training, exactly. Vocational or licenses that take 1 or 2 years to get. But yes, you do have to prepare your people to operate the service. If the people aren't there, who's gonna run the trains for you?
So one thing is, how big do you think is 50 years? When you design structure today, it feels really long, right? But we are able to review 50 years in 4 slides. and that's the beauty of it. Like, the time passes actually very quickly, and when we design things for 50 years, we feel like it's a long, long time that's not going to impact or that's not going to matter. But some of these infrastructure becomes so critical part of the function, the way to serve the country or the needs of the country, then they become indispensable. And now you are stuck with them, a poorly planned at 50 years ago. Not only the fault of a person, it's hard. It's hard to predict the future of 50 years later, right? Who would have thought in 2007, just before Steve Jobs launched the iPhone, that from tomorrow onwards, the world is going to change completely. So it's not a fault of a person who's trying to design this, but these are the challenges that always becomes very interesting. And another thing is, you see in each phase, the challenges are drastically different. When you're beginning, you are struggling about how to get it running. You are still struggling about how to get it running, but from completely different reasons, right? So this is also very interesting that around the same core technology or the same core piece of infrastructure that you want to do, the risk would manifest in very, very different format. What was the problem 20 years ago is not the problem now, versus what's the problem, like at that time nobody was thinking, it's coming up, really becoming an emerging problem, right? So this is the really long-term perspective that this course also tries to bring a little bit. Think long-term, how could you assess some of these things? Of course, forecasting related questions are challenging. Nobody can give you a good forecast. But I just wanted to emphasize that, planning horizon and long-term thinking is one of the ideas that we want to leave with this particular class.
Yeah, I'll start the next part, and then I have a couple more discussion exercises here because I want to get some more information from you as well. So I'll introduce the topic first, okay? All right, so once again, sorry, I repeat things a lot because I'm also trying to tell the story consistently in my mind. So the subtopic is developing and managing good infrastructure systems. I started with the infrastructure systems framework, and then I gave you some examples about Japan developing and managing their Shinkansen system. So now I want to think about how difficult it is. I like this word good, but it's not a simple concept. The good. We have to build a good system. What does that mean? Defining good infrastructure. Good for who? That's the key question for me. All right, stakeholders in a high-speed rail project. Yeah, I think this is good. We'll have 10 minutes before the snack comes, but I want you to discuss until the snacks arrive. Try and have as open mind as you can. Think about how many people will be affected by a high-speed rail project. I guess we'll focus on the existing one that's under construction right now, just so it doesn't get too abstract. But think about either groups. So what I mean, groups could be individual companies or governments or anything, any sort of group, or individuals, types of people, maybe communities or individual characteristics. Who are the people that will or might be affected by the development of high-speed rail? I would say it's, especially in the Japanese model, it's very much built into the thinking, system development and system evolution. So iterations and constant updating of standards is part of the, I want to say 5-10 year horizon of any even development or manufacturing contract. And I think it's interesting to think about who should drive that development. So in Japan, it might be the Japan Rail would push their manufacturing subcontractors or the industry to say, we need a safer bolt, we need a faster nose, we need more durable wheels. They demand it from the market, right? And then that's how you can drive it. And so from what I know about at least the Indian context of using the Japanese technology, usually Japanese infrastructure exports do have a capacity building package attached to it, meaning that they also want to train the engineers so that they are not dependent on Japanese engineers after 10 or 20 years or something. It's part of like an exit strategy. Japan does not want to be here for 100 years. We want to help you use the technology and then leave. That's part of the pitch of the selling it. Capacity development is what they call it. But yeah, as you say, it's definitely, I think, it's interesting thinking about whose job it is to then say, okay, do we take that technology risk, or the Indian industry has to develop its own technology and make this technology basically, redundant after 20 or 30 years and replace it slowly. And we also talk about that in terms of maintenance management, but it's very dangerous to think you have this fixed facility and let's just extract as much value out of it as possible until it becomes zero and throw it away and get a new one. That is very dangerous for like a running service, like a rolling service like this, right? You want to constantly make sure it's safe, and that's part of the mental models of infrastructure services, I think.